Okay, we're looking at the practice paper from the textbook and we're on to question 2. Okay, so this is coordinate geometry. So we've got a straight line and we want the equation of a line that's parallel to this one. So obviously we're going to look at the gradients and then we're given a point that it goes through, and it just tells us A and B are rational numbers. So that does not mean that they have to be integers. Okay, so first things first, I want to get the gradient. So there's the, write down the equation that they gave me. I don't actually need the full rearrangement of that because it's only the gradient I need. So if I add the 3y over to the left-hand side and then divide by 3, so the 4/3, I mean, I might as well write it, but the 4/3 really isn't what I need to know. It's the gradient that I want. So if the gradient of that line is 2/3. Oh, I was going to do perpendicular, but reading it again, I want the parallel gradient. So that's going to be the gradient of the line. And I'm given a point it goes through. So I am going to use y minus y1 is m times x minus x1. So, and my coordinates they gave me in the question 5, 6. So y minus the y coordinate is the gradient times x minus the x coordinate, and then they want it in the form y equals mx plus c, basically. So normally I'd multiply it by the 3, but I'm not going to do that for this question. I'm going to just multiply those brackets out. So it'd be 2/3 x, and then 2/3 times 5 is going to be 10/3, and then I need to add the 6 over. So 6 would be 18/3. So if I'm adding that to minus 10/3, I make that 8/3. And I think we've got that in the form that they wanted. So it just said A and B are rational. So the fact they're fractions is absolutely fine. And let's just check our answer. Brilliant.